Hey everyone, in this video we'll be continuing on with the SageMaker Inference and Hosting series. And this is probably a direct follow-up to the different LLM hosting options that we were talking about. You should see it right above in the playlist. But what we'll do is we'll explore one of the options that we talked of. We've already kind of done a hands-on on Jumpstart that I'll link down below, but what we'll specifically explore today, as you can see in the agenda, is the large model inference container. And we want to talk about how we can essentially integrate that within SageMaker real-time endpoints, and we'll get hands-on in this video and go into the code and see what exactly you can set up there. But before we do that, right, we'll, as usual, kind of have a bit of a theoretical breakdown where we'll talk about the different kind of serving backends that are available for LLM inference via this container. What exactly can you optimize using these different backends, and why is this container so powerful when it really comes to working with LLM hosting and serving? And with that being said, I'll hop into the whiteboard directly as always, and just we'll spend a few quick minutes exploring what this container is, what exactly it enables, and I'll surface the relevant documentation for you and link it below as always too, just in terms of you understanding more about the structure of the container, kind of the different concepts that we talk about here, and then we'll get directly hands-on too as always. So within the LMI container, right, and we talked about some of the specific challenges with LLM hosting from the model size, and then factors such as the KV cache. And all this led to us understanding computationally hosting LLMs is going to be very, I butchered the spelling as always, is going to be very expensive. And we definitely need GPU instances or machines where we have multiple GPUs available for the most part to be able to work with hosting. And there's many different serving engines that have been introduced recently, and a lot of them are also OSS that are available. And some of the ones that you might hear of or that are really popular in the industry are TensorRT LLM. This is by NVIDIA. There's also VLLM, and then the library will explore specifically within AWS itself, known as Transformers Neuron X. These are all different LLM serving engines, just like a traditional model server, but tailored for LLM serving in specific, that have been created to address many of the different challenges that we talked about with hosting LLMs. And they do this by enabling different optimizations, right? And we'll explore some of these in our hands-on different optimizations, such as tensor parallel, where you can essentially shard the model across multiple different GPUs. Most of these models are not going to fit into the memory of a single GPU, so we need to be able to shard this model while retaining its data science state and accuracy, and be able to fit it across multiple GPUs in a machine. And this also helps with inference speed and latency in that sense. We also talked about different kind of optimizations such as server-side batching that you can enable. And then we won't explore this too much today, but there's also things such as quantization and different kind of lower level optimizations that you can do that are really enabled through not all of these different serving engines front these different optimizations in the same way, but you can think of these as some of the standard ones that are really introduced to really improve LLM inference and speed when we're talking about different SLAs such as latency and throughput. And what the LMI container does is, right, it surfaces all of this into a single container and exposes these as different backends that you can choose from. So let's say that you're really familiar with VLLM. You can essentially take the LMI container and specify that you want to use the VLLM backend. And within the VLLM backend, you'll have access to all the different kind of optimizations or properties that VLLM traditionally would expose for you to kind of work with and set up as environment variables for your LLM serving. So the right decision to make here, right, in terms of which engine or backend you want to use is really your own familiarity and comfort. So if you want to go with using TensorRT LLM, for example, if you're more familiar with that, you can go that route. You can go the VLLM route, which is another OSS implementation of a serving engine, LLM serving engine. And Transformers Neuron X is specifically within AWS for serving these LLMs and compiling and serving them on the Neuron Inferentia 2 chips, which are special kind of chips tailored for ML inference and training. So there's different options that exist within here, and what I'll do is I'll really quickly hop in now to the documentation itself so that you can see this, and I'll link this below. If we go to this DGL serving documentation, which is the engine behind the LMI container, you'll see that if we come to this table of contents, you'll see that there's essentially different user guides or LMI inference libraries that are supported here. And these are the different backends that I was talking about. So we have VLM, which is a OSS LLM serving engine, LMI dist, which is, I believe, a adaptation of VLM, but with some other features that have been introduced or some other model family support. TensorRT-LLM by NVIDIA, and then Transformers Neuron X, which enables you to work with those Inferentia 2 instances that I was talking about, those special chips that exist within the AWS ecosystem. And if you see here, much like we've talked about before in SageMaker Inference, there's managed container images that are available for each of these different backends. So depending on the backend that you choose to use, once you're working with the LMI container, you can select the appropriate available managed image here. And like always, once again, you can bring your own and expose the necessary port for inference there and set up serving. But it's very much simpler, in my opinion, to at least use one of these managed images just because it takes care of a lot of work for you. And these are vetted and kind of maintained by AWS itself. And specifically, right, if you want to understand more in terms of what's available within each of these different backends, you can go to the different user guides that exist within here. So for the different kind of serving stacks that we we're talking about, you can see kind of the model families that are supported, for example, within the LLM. And then you can also see the different kind of properties or environment variables that you can essentially tune or optimize or load test across. So if you want to test different combinations or iterations of these different kind of features that are available, or these different types of optimizations that are available, you could also do that. And those kind of arguments and properties are all available within these different user guides for you to understand. With that being said, right, what I'll do is I'll hop right into the notebook just so we can get hands-on directly. And this will always be in that same GitHub repo, that inference video series kind of stash right here that we have with all the different code samples. So you can go there and clone that repo. Today I'm working in a SageMaker Classic notebook instance. You can do this on Studio. You can also work locally wherever you are basically authorized or authenticated to be able to work with SageMaker itself. If you do work locally, the one thing I would say to make sure not to do is do not pull these model artifacts for these LLMs down locally by accident. Your computer probably will blow up. Not literally, but like when you're downloading a file of that size, metadata of that size, right? It can be very, very heavy. And right here in this classic notebook instance, so we can get started. What I'm going to do is I'm going to take a Llama variant. There's a open source kind of reproduction of Llama on Hugging Face that you can directly grab. I've linked it here. What I'm going to do is I'm going to take this, I'm going to leverage this LMI container and use specifically the NVIDIA's TensorRT LLM backend in this use case to showcase how you can use LMI in conjunction with everything we've learned with SageMaker Real-Time Inference itself. And in terms of getting started, right, our tools or kind of the point of contact or SDKs that we're going to be using are the exact same. We'll use Boto 3, the low-level Python SDK, to interface with SageMaker and create those SageMaker-specific constructs. We'll use the higher-level SageMaker Python SDK kind of for any utility functions, like retrieving any images that we might be working with. Now, the key part specifically for LMI itself, right, is there's two ways you can surface this. You can either, two ways you can surface the different properties that you want to tune or enable for your LLM serving. You can either share a serving.properties file, kind of like we've been doing in our CPU implementation. So if we go here for way back in the series when we deployed the scikit-learn model, you'll remember that I actually created a serving.properties file and to specify the engine as Python. This is because we were just working with the base CPU workload and we didn't have any LLM specific properties that we want to set. You can do this, or even easier, you can specify a dictionary object, a Python dictionary right here with the different environment variables that you want to tune. So you can keep the serving load models the same. This is essentially how SageMaker's going to store the model artifacts in the directory within Docker. So just keep that the exact same. Here we enable a few different flags or parameters and variables here, and you can add more if there's things that you want to test out, but I have some of the standard ones. One is tensor parallel, and like I said, we can't really fit any of these different LLMs into the memory of a single GPU. So what we do is we pick up on the instance type or hardware you're going to specify behind the endpoint, and we say whatever amount of GPUs there are, shard this model across that amount. And I think in this case, I'm going to be using a G5 12x large, which has 4 GPUs. And essentially, right, when I say max here, I'm telling DGL, shard this model across the 4 different GPUs. And that's essentially the kind of, you can set max here, but if you have a certain amount of GPUs you want to split it over and you know that that LM works across, you can also enable that. A few other optimizations I do here, and I'll hop back to this model ID flag in a second, is rolling batch and max rolling batch size. This is a server-side batching that I'm enabling essentially. And all these engines or backends do this in different ways. So what we ask is specify the rolling batch in terms of server-side batching for the backend that you're going to be using, which is TRT-LLM in this case, and it's going to get structured in the format that NVIDIA's TensorRT-LLM expects. And then you can specify a batch size. So this is your server-side batching that you can enable essentially. And this comes optimized for LLMs in specific, where you can factor things such as the KV cache. And we'll dive deeper into those optimizations in another video in the future right there. The key part here, though, is for understanding the model data you're working with itself. You can specify this feature, or you need to do this actually, this model ID feature, where you can say a Hugging Face model ID. And what happens is the container will automatically pull down these model artifacts for you. So this model data underneath the hood, it gets pulled down within the SageMaker endpoint when we're creating this, because we specify this model ID here. Optionally, if you don't want to pull it from that public Hugging Face repo, you can pull these model artifacts into S3 itself and specify that S3 model data path here. So this would be something like S3 model data location, whatever you're working with here in specific. You can specify that there. And that's mainly it in terms of the different features that you can enable here, or the different parameters you can set up. And like I said, there's in these user guides, you can see all the different parameters that are exposed via these different backends. Then what I do is I specify the image URI for TensorRT in specific, and if we remember, that was in the documentation, so I just grabbed it directly from there. You can also see that available images kind of repo that AWS maintains to see what the latest might be there. Then it's kind of business as usual. We specify the same SageMaker constructs, the model, the endpoint config, and the endpoint. The model, once again, we specify our container. We specify this environment dictionary here, which is pointing towards our model data. So traditionally, we'd have an S3 path, right, with the model data key here. We're instead saying in this environment key right here, look into this environment dictionary, and that's going to be pointing towards the model artifacts that need to be pulled down. And that's neatly pulled from that Hugging Face repo or that S3 path that you've specified. We then create our model object. We create a endpoint configuration object here, where we specify our GPU instance, a G512X large right here, which has 4 GPUs behind the instance itself. And you can check all this on the SageMaker pricing page as well. I'll link it down below for the different GPU instances that are available in terms of what you would like to use with your model itself in terms of hosting it. And then we specify the instance count to 1. We're not going to enable any auto-scaling here. We set the container startup health check timeout to a little higher here to 60 minutes, because this is going to take a little longer, obviously, in terms of pulling down these model artifacts and passing that ping health check. And then we also enable a routing config for least outstanding requests here. And this won't apply much because we only have one instance here. But the reason you should get familiar with this is this is another way to kind of optimize for latency here. Because what we can do is by enabling least outstanding requests, and I've linked the blog here, if you have multiple instances behind the endpoint, SageMaker will smartly route the requests, the invoke endpoint API calls that are coming in to the instance that is best fit to serve that traffic at the moment. So if it has the least amount of requests coming in there, you can enable LOR here. I think by default it's random. I might have to double check that, but there's two values you can enable here for this key. It can be random or least outstanding requests, but this is good practice if you have multiple instances behind it and you want to really optimize for the inference or latency speed of the endpoint response. We then create the endpoint. Like I said, this is going to take longer than a CPU-based model just because we have to pull down these model artifacts that we're working with. And then once this is created, you can see in your inference console, as always, the different endpoints that are available. And if you see here, I've also attached a sample inference. Probably need to tune the parameters to be able to generate more tokens, but you can see inference is working kind of as expected. And what I also recommend looking at, just for your own understanding, if you go to this endpoint here, you'll see that there's model container logs that are built in and enabled for you, just like with any SageMaker endpoint. But you can also understand the behavior of this container a little more. So if I go to, I created this in the past hour, if I go to when I first created and launched this container, you can see that DGL serving engine is being set up. You can see it's picking up on the number of GPUs and essentially the different serving that properties or environment file that you've enabled essentially. And this is all kind of what you're passing in and configuring specifically with what you're dealing with. And if you scroll down, you'll also see through time those model artifacts are being pulled from that Hugging Face repo that we've specified, and it's getting converted into the format that NVIDIA's TensorRT-LLM serving engine expects. So all of this is happening underneath the hood for you. That convert.py is structuring it in a format that TRT-LLM can serve. And the same happens with VLM or Transformers NeuronX, whatever kind of backend library you're using that's supported. And once these are converted and enabled in the format that's expected for serving, you can then essentially have that endpoint created, right? But yeah, that was mainly it there in terms of those logs. Just want you to get a better understanding in terms of what's happening underneath the hood. Please make sure to delete this endpoint. It's a GPU instance, so it's far more expensive than the smaller CPU instances we were working with. So just not to incur any other costs. But yeah, I think that's mainly what I had for all of you today. I hope it was a useful introduction to the LMI serving engine itself. What we'll do in follow-up videos is we'll leverage this container along with TGI from Hugging Face to maybe showcase how can we deploy multiple LLMs on a single endpoint, and why can't we use MME, which we talked about multi-model endpoints before, to really do that. And that will introduce us to a new construct in SageMaker Inference known as SageMaker Inference Components, which allows you to efficiently host multiple of these LLMs and scale them. So we'll get pretty hands-on with it. I know I introduced it a little earlier, but we'll really see the power of this container then and using it in conjunction with the features such as inference components where we can really build a production grade type of kind of app where we have multiple LLMs being served efficiently on a single endpoint from both a cost and performance perspective in a very efficient manner. So yeah, I think that was mainly it for today. As always, if you have any questions or want to reach out, please leave it below in the comments or reach out to me on LinkedIn and Twitter. And if you like this video or found it useful, please feel free to leave a like and subscribe. I'll be back very soon. Thank you as always.